Welcome to Lesson 1 on collision theory and factors affecting reaction rate. Our lesson objectives determine the effect of effective collisions on reaction rate and determine how factors affect reaction rate according to collision theory. This unit is going to focus on the study of rate or speed at which reactions occur, which is called kinetics. And a reaction is the breaking and the reforming of bonds to make entirely new compounds as products, and these products will have different properties than their reactants. So an example here, when we form CO2 from our reactants CO, carbon monoxide, and oxygen, we have to first break these individual bonds here between the C and the O and between the two oxygens, and then form new bonds when we make our product CO2. And recall that when we break bonds, we have to put energy in, and when bonds are formed, energy is released. And so overall, the delta H, the change in energy of the reaction, could either be positive or negative, meaning endothermic or exothermic. If you're putting more energy in than you're getting out, you are endothermic, and if you get out more energy when the product's formed than what you put in to break them apart, then you would get an exothermic reaction and a negative delta H. So in order for these reactions to occur, though, we must have our reactants particles colliding effectively with the following two criteria. They must collide with the right amount of energy in order for the reaction to take place, and they must be orientated or angled properly. If one of these criteria are not met, then the reaction does not occur and we don't have an effective collision. And so particles are colliding all the time, but again, not always effectively. So they need to meet those two criteria. So for example, for this reaction to take place between hydrogen and iodine to form HI, we must have the right angle or orientation and the right amount of energy. So you can see here's an example of improper orientation. You can see they're not aligned properly. This H is going to interact with this I, but the outer H and I are not going to collide or interact, and therefore this reaction won't take place. In this example here, we're demonstrating not enough energy. So without improper energy, without sufficient energy, we do not get the reaction to take place. And finally, here's an example of the reaction taking place. We have the right amount of energy, and you can see now they are oriented in the right fashion, so therefore this H will interact with this I, and this H will interact with this I, and we'll get our reaction taking place and our products being formed. So there are 6 factors now that will affect the rate of our reaction and our effective collisions. And they do this by increasing the number of effective collisions that are happening. So the more effective collisions we have, the faster reaction will take place. And again, remember, there are collisions happening all the time, but not always effectively. So the more times you collide, the better chance you will have an effective collision, and then of course the faster the reaction will take place. Let's check your understanding. Determine the effect of effective collisions on reaction rate. So let's go through the different types of ways that we can speed up our reaction. The first one is the type of reactant. Ionic substances, if they are in aqueous solution, have already dissociated into their ion, so they'll react faster. As you can see here, we put silver nitrate into water and form an aqueous solution. The compound is already broken down into ions, so that first step is already done, so the reaction just takes less time and therefore happens faster. Compared to covalent substances, we have to first break the bonds and then reform them. So it's just more steps, more energy, and therefore more time. Let's check your understanding. Can you determine the effect of effective collisions on reaction rate? The next factor affecting our reaction rate is the concentration, the amount. So if we increase the concentration, we're going to increase the reaction rate or the speed at which the reaction occurs. As you can see here, for low concentrations to high concentrations, if you have more particles, they are colliding more and more chances for effective collisions to happen. If you have more effective collisions, the reaction will happen faster. The next factor is temperature. When we increase temperature, we're going to increase our reaction rate as well. And again, this is due to the increased number of effective collisions, as well as the reactants having more energy when colliding because they are moving faster. They have more kinetic energy. And so you can see here, cold versus hot. You can see the particles are moving faster. They're colliding more often, and therefore a greater chance of these effective collisions happening. And when we draw our particle models, we can show that with longer arrows here, indicating more movement or a faster speed, and again, resulting in increased effective collisions more energy, a faster reaction rate. So let's check your understanding. Determine how concentration and temperature affect reaction rate according to collision theory. The next factor affecting reaction rate is dealing with pressure. Now this, again, only involves gases as we discussed in previous units. But when we increase the pressure, we're going to increase the reaction rate. And here's why. When we increase the pressure, you can see here as we decrease the volume, here you'll see the particles get closer and closer together. Or you can see here in this picture as well. Increasing the pressure by decreasing the volume pushes the particles closer together. So essentially, you're creating a higher concentration in a given space. So if the particles are closer together, it's going to result in more collisions happening and a greater chance for effective collisions, which speeds up the reaction. The next factor we're going to look at is surface area. Increasing the surface area increases the reaction rate. This is due to more exposed particles that can react more effectively. So if you look here, here is a very small surface area. You can see that the particles here, the solvent, can only interact with the outer particles, and so the inner atoms are left waiting to react, and then that will then happen now, which takes longer. Now if we break this crystal up into smaller pieces, increasing the surface area, you see here, now the particles can all interact at once, and therefore the reaction will happen faster. So small surface area, as you can see here, not a lot of exposed areas to interact, more surface area, more exposed areas, and the reaction happens faster. We have more collisions taking place with all of the particles at once. Let's check your understanding. Can you determine how pressure and surface area affect reaction rate according to collision theory? The last factor we're going to look at is adding a catalyst. A catalyst is a substance that increases the reaction rate, the speed of the reaction, actually being consumed in the reaction. So we can use it over and over and over. And we have many types of catalysts. In our body, we have biological catalysts called enzymes. And they get used over and over. And they speed up the chemical processes going on in our body. And so if this is our reaction taking place, and we have to get over this hump in terms of putting energy in, then a catalyst is essentially going to give us a different pathway that requires just a little bit less energy or even a lot less energy, and therefore the reaction happens faster, we get to our products faster, and the reaction rate, the speed at which it occurs, happens faster. And we're going to see a few examples of this in class, one dealing with the elephant toothpaste demonstration and a few other reactions where adding a catalyst will speed up the reaction. Let's check your understanding. Can you determine how adding a catalyst affects reaction rate according to collision theory? At this point, you should be able to determine the effect of effective collisions on reaction rate and determine how factors affect reaction rate according to collision theory.